The Apple Valley Model Railroad Club presents Modeling Basics 101. This six-part series introduces you to the exciting world of model railroading, covering everything from initial layout design to final scenery. For more information about the Apple Valley Model Railroad Club, visit their website at avmrc.com. Part 6. Cutting and Replacing Track.
This is presentation number 6. What we're going to be doing is in a module that has been completed or almost completed, and then we're looking at whether or not you found for this example, switching from the main tracks, or if you have a siding that you wanted to do, but you've got all of your scenery built and everything, how we're going to kind of dismantle and then create the new piece, what we're doing with the turnout and so forth. So we have Mike here who is going to demonstrate and show us what we need to do, what are the do's and the don'ts of cutting track and placing a turnout and all that. So Mike, all yours.
Good morning. Today I'm going to suggest to you, do not be intimidated by hacking up your layout to put in transitions or turnouts or anything else. It's not that hard, and today this is what I want to show you. Today what we're going to do is we're going to put in a crossover from main line A to main line B. Okay? That's a typical scenario where you'd want to cut in 2 turnouts. You can do a single turnout off of a siding to create a subsiding or anything else that you want to do. It's all the same technique. The first thing that you want to do, and I'll go over 4 different tools that you can use and what the pros and the cons are of each one, okay? The first thing that you want to do is you want to make certain that wherever you're going to install your turnouts, you secure your track very securely between the entry point and the exit point. And that's to keep the track from moving on you when you're going to be doing your cutting and putting in the turnouts. So with that, we're going to go over a couple of tools that you can use, okay? And the first tool, these are Xuron tools, or XLs, but Xurons, okay? They call this a track cutter, and supposedly it has a flat back on it. However, when you're cutting track with this tool, it will cut cleanly. However, what it will do is, because it's a compression device, it will create a pinning or a cavitation of the, a cathedraling of the track, okay? In which case you go to step 2. So this is a 2-step tool, so that's step 1. And then you would take a file, a Riffler file or a flat file, and just file them square so that the rail is very square on the edge, okay? So it's a good tool, it works, but it does leave you to have to do a secondary step, and that is with a file. So you got to file your rails, okay? The next one is a little bit different. This also is a rail cutter, but this one truly has a flat back on it, okay? And this one will also cut rail, but it leaves it a little bit better. So you can see that it's almost really square, okay? I don't like almost really square. So I tend to use these as the bulk of the work to cut out large sections of where I want to go, but go in and do a fine tune. And I use an Atlas, this I believe is an Atlas micro saw, okay? They're about $4, $5. They're dirt cheap, okay? And what this will do is this will give you a very nice square cut, okay? So the first thing you want to do is line up your turnouts where you want them to be, and then put a sort of a mark where you want them to line up, okay? And what I've done is I took a Sharpie marker and I just marked where the beginning and the end point is of the turnout and this turnout, okay? If you don't do that, you can use the turnout itself as your guide with the saw, which is nice. okay? Because you can control this saw, and it's a very fine cut, and it will cut through the brass rail, not a problem. Yeah, very handy tools. Okay. Takes a little bit of going, but it'll get there, okay? This saw is kind of worn out, which is why it takes a while. But this will cut, very nice clean cut, okay? So my preference is to use one of these. If you're really into getting it done quick, use a Dremel, okay? And you can use the Dremel tool, but you have to be mindful of the thickness of the cutting disc so that you're going to cut not to the inside, but to the outside mark, okay? And you want to watch your eyes with this and try to come down square. That's the toughest part. Yeah, one more time. Come on. Just about there. Okay, so that cut through there and there.
So I have a question for
Yes,
you, Mike.
go right ahead.
When you're cutting the track, are you cutting it right next to a tie so that you give enough
Does
of
not
the rail?
matter yet.
Okay.
Okay, that really does not matter too much whether you're between a rail, on a rail, or whatever, because the next step is to take care of that. Okay, so let's cut this side out. Yep. Okay.
Question.
Yes.
I have an older Dremel.
Yep.
Wired.
Yep.
So if I did that, I'd come in at a slight angle. Is that going to hurt anything?
Well, that's one of the things you want to be careful of, and it's okay as long as you're close enough on your cuts so that the rails join up close enough. If you have a slight gap, not a big deal. Yeah. If you're going the other way, then you might have to trim a little off with a file. Yeah. So it all depends on which way you're leaning on that.
I use these and I use the Dremel.
Okay.
That was a good question, because the
Yeah.
first time I used a Dremel, I have a corded one.
Yep.
Did the same thing, because you have to hold it at an angle.
Yeah, yeah.
And you don't get a straight.
You don't get a straight cut, and that's why I like to go back to the saw.
Yeah.
And when you have a new saw, this will actually cut very nicely and very cleanly, okay? So,
Mike,
Yep.
What are the discs for the Dremel called? Disc?
that one's a cutting disc. It's a diamond-tipped cutting disc.
You can also use the flat ones.
You can use the flat ones that are just grit.
Right, that's what I've got.
Yeah, and this one's a neat one because you can cut anything with this one. You can cut through hardened nails, you can cut through tools
Will the grip
eventually.
Cut the rail?
Yeah.
Yes, it will.
done it, yeah.
Yes, it will. Okay.
But it's wider, I think, isn't it? 'Cause I have a different cutting disc.
Yeah.
And it's too wide. I was cutting and it's like.
Well, see, that's the problem, and that's why I say there are pros and cons to each one of these. The other thing is, if your hands get a little shaky with these things, you're going to end up with a ragged cut. That's why, again, I like to go back to a razor saw and cut out with a razor saw. Okay, so now that we've got that taken out, we'll just double check for a fit. And there you go. You got just enough gapping in there. And this rail actually is cut at that angle that you're talking about. Okay. So you're going to end up with a little bit of gap in there. But this gap is certainly not an issue. Okay? It's actually good because when you get into the expansion, contraction, humidity changes and what have you, turnouts are the first thing to get violated, and they want to compress and they want to change gauge very rapidly on that. So a little bit of gap is perfectly fine. It's not a problem, okay? So the next step, and Tom asked, is it important to be between a tie, on a tie? Really doesn't matter, because we're going to take ties out. So what you're going to do is you're going to go back now, and you're going to go back at least one tie, and you're going to clip the rail head or the nail, the molded nail on that, okay? And you want to do that because you want to be able to get a rail joiner to slide up all the way up onto your cut rails. I think we got it, okay. And then this one we can actually cut out or leave it in, doesn't matter. Okay, so what we want to do is make certain that we have a clear path for the rail joiner. Okay. There we go, okay. So once we clip those, then you can take a rail joiner, which I believe are here. Where do we put the rail joiners? Yeah, okay. Shaky hands. All right, we may have to pull this tie out. There we go. Okay. So what we want to do is we want to be able to take out enough ties, and I got to clip another one to be able to slide that rail joiner all the way onto this track. I don't think I'm clear. Okay.
So is the rail joiner going to go over top of the tie? So you're not...
Yes.
Okay. So we're not eliminating the tie unless we need to?
That's correct.
Okay.
There we go. Okay. So that's what you want to do, is you want to get that rail joiner slip all the way up onto the main rail. Okay?
Eliminate this step if you choose to run feeder wires to the switch and then just leave the gaps.
You can if you're sure that your rail's not going to move. Okay? But, you know, I'm a proponent of rail joiners. It just keeps everything, you know, in line.
That one.
That one, you're absolutely correct. Or it doesn't matter. How about this one? Okay. So now,
why are we putting the rail joiner all the way in? Wouldn't you want to have a little bit so that the other...
you can't get it in.
Yeah.
You won't get that piece.
You won't get this piece in.
Ah.
So what you want to do now is you set your track where you want to be, and now you can slide your rail joiner forward and pick up your turnout.
Okay.
Okay? So you're going to do that.
All four rails.
You got to do it on all four rails, all 6 rails. Well, all 4 rails, because these 2 are just going to join naturally with that. Okay?
So you won't need a rail joiner on this part?
Well, you will, yeah,
okay.
you will. But they'll be joined. I mean, you don't have to cut ties on this one to do that. You only need to cut ties and go through that machination on the infeed and the outfeed of the track. Okay? So once you get that, once you get that lined, then you can get that. You can slide those rail joiners and join the tracks. Okay? So let's do the other one. See if I can get that. And going back to where I need to cut. Try to get that knife under the rail and just clip those spikes.
On the turnouts, if you got your plan already set up and know where it's going, it's best to put the turnout on with the track at the same time, like if we knew that before this part, right?
Oh, yeah, absolutely. However, you know, you're always going to want to go back and modify your railroad, because after you build it, you're not going to be satisfied with certain things. And so you're going to want to change, add, modify, subtract. And this is just one way to add after it's already built. Okay. So.
Yeah, you figure you spend 2 years putting your model together, and then 6 months later you go, gosh, I could put a siding right here.
That's exactly
Let's do
right.
that, right? Because once you get the bug, my guess is
Yep.
you're always fiddling with your layout, trying to do this, that, the other thing. And so this is kind of why I wanted this presentation, was to say, okay, how do you do these kind of things?
Well, it's the old adage, your layout is truly never finished.
Yeah.
Let me check this one out of here. There we go. Okay. So the toughest part of this is going to be to get the rail joiners on. Number one, if you're shaky as me, but then this is why you want square cuts and clean cuts on the rail. Because if you have any burrs on the rail, it's just going to make it tough to get these rail joiners on. Okay? So now,
If the rail joiners and the track are the same manufacturer, do you find them to be completely different?
I've actually found that I like Pico joiners better than Atlas joiners. And so on Atlas track, I'll use Pico joiners.
Okay.
Okay? Mostly because they're a tighter joiner than the Atlas. The Atlas leaves you with a little bit of slop in there, and I'm not real happy with the amount of slop movement that you end up with an Atlas joiner, because they are somewhat looser. So again, we want to try to get that. Yep, we're hung up on that tie.
Well, Mike is getting his rail joiner there. With the turnout, Mike, can you kind of explain how to wire that turnout to your track, because we already have wire and stuff, but I believe it's a 3 type connection, right?
Well, it depends on whether you have an electro frog or an insulated frog, and the frog being that point on the turnout right here. Okay, with an electro frog, this is conductive and it's metal, and so the advantage of that is if you're running real short engines, 4-wheeled engines, you may have stalling issues when you go over these insulated frogs. So you can go to a powered frog, in which case that's your 3rd wire. So that wire would then be soldered onto the underside, because they give you a soldering tab on the electric frogs, the electro frogs. So you'd solder a wire coming down.
And that would actually then
that will change the polarity of the frog to match the rail, depending on whether you're going in or going through.
Where does that wire go?
That wire would go to if
your
you
bus,
had,
right?
Oh no, that wire would go to if you were using tortoises. Okay, there is a single pole double throw switch on that tortoise. So a single pole double throw switch will give you an either or logic. Okay, so that would get wired to the center pole of that tortoise connector. Okay, and I forget whether it's pin number 6 or 7. Okay, and then the other 2 would get connected to inner rail and outer rail.
Right.
Okay, so now every time the turnout changes, the movement, it changes the polarity of the center to match the rails. so that you don't have a conflict and a short circuit going in.
For me, because I was gonna do manual throws, which I did.
Yep,
But but there was no connectivity between this and that. Oops, sorry.
yep.
So I had to crosswire this one to this one and that one to that one.
Yes, on a lot of these turnouts, what they rely on is the connection point of this turnout touching the stock rail. And the problem is they oxidize, they get bent, they get a little bit of dirt in there, and then they don't conduct. So you have power coming in, but no power coming out. And that's what you end up with is dead rail.
And that's why I had to.
In which case, then you crosswire it, yeah, and you'd be
crosswire 10
done.
of them.
10 of them, and be done with it, yeah. I've been there. Been there with that, done that too.
Like with the newer switches, typically come with the wiring in place, though. Is that true?
I believe the Picos do. Okay, I'm not sure about Walters or Atlas.
I have microengineering, mine were not.
They were not, so,
They rely on electro switching, which I didn't do.
Yeah,
Yep.
Pico's that were wired, but I didn't know if the other brands had.
okay. All right, so we're back to just trying to get this.
Pain in the butt.
Well, we're running into this tie, and it's nothing more than a piece of plastic that's inhibiting the movement of that all the way. So what I'm going to try to do is just get the rail up in the air a little bit and push. There we go. Okay, that'll do it. Okay, so now once you get your turnout put in, you can slide your rail joiners onto your turnout. You just pull them forward and you should be able to, you will be able to get them lined up. You just have to work at it a bit. Okay, and I think what I do is I put a dingleberry in the in this turnout, in this one right here that I struggled with. So it's not going to want to go on. Okay, but you get the idea?
Yeah.
Okay. So you're going to do that on this one, and then you're going to do the same thing on the opposing one. Okay? And with that one, what I'm going to do is I'm actually going to cut through with a saw because it's just so much nicer cut. And I did mark where that turnout goes with a Sharpie before, so. And that's through, okay? So you see it cuts nicely, okay? I like this saw a lot better than I like the Dremel because the Dremel is just like throwing a shotgun at mosquitoes. And here's the other mark. Yeah, that's why you want to make sure your rail is down tight because it's going to want to walk on you. That I believe is through. No, not quite.
So
There it is.
in the case of having ballast on the rail, that would be enough to hold it in place to cut the track?
Yes.
Okay.
Actually, my preference would be to ballast first, you know, or make sure everything is down tight because the ballast will hold your track down nice and tight. And you won't have to go through this. Okay? There we go. Okay, so you go through that scenario and you do the same thing on this track that you did on this track. You slide your joiners on after you clip the spikes. Slide your joiners on and put them in place. And you're done.
Looks good.
Okay? Not bad, right? Okay. So the reality is, I don't want you to be intimidated by going in and having to hack out, you know, a section of rail to put it in. I mean, it's just a couple of simple steps. Okay?
Mike, I may have missed this when I went to the restroom.
Yeah.
But the way that we wired our layouts, you're gonna have a conflict in the polarities of.
Right.
Okay.
Right. We so the way we wired was that at the end here basically is a loop, right? So I'm not sure if it's black, red, red, black. So when you loop it, it looks like it's just an oval, right? In your layout, you would never want to do that. It would be black, red, right? Because they're two independent tracks. So just to let you guys know that when Dan did his presentation, he assumed that we were going to connect this track together to make it an oval. So this is what we did really is not typical of what you should be doing, okay?
I don't know how you wired it, but yeah.
Right. I'm
Yeah.
good. Yeah, that was something that I was struggling with when I was wanting to wire it, and then when I talked with Dan and what he said was like, okay, this is how we're going to do
So
it.
it should be red, black, black, red?
Red, black, red, black
Yeah, that's
is
the way it should be.
typical
Yep,
for a
that's
layout.
typical.
Yeah.
What we did was red, black, black, red,
we thought
because
it was gonna be
there's going to be a loop to come in there. So basically, it was an oval.
Are we ever gonna make that? Are we ever gonna make that loop?
Probably not.
Okay.
Because each we have our own module that you're going to do whatever you want with it,
So I
right?
can wire it.
You can wire it however you want after we're done with the class. Okay. So yeah. So getting back to this scenario. So right now we've got our track wired, but this is not wired. So do we have to wire here, here, and here?
No,
Or-
the rail joiners should make the conduction between all of those points.
So,
So
what
as
about
long as
what
you're-
about this one?
No.
Okay,
The
I'm
same
sorry.
thing, you're going to put rail joiners there.
Oh, okay.
Yeah, so they'll be joined, electrically joined through the rail joiners. Not the best scenario, but okay for what you want to do, okay? Normally, I would solder the rail joiners, or I would put wires, I would drop wires to the turnout as well.
So you're gonna want 10 rail joiners.
Yeah, 2, 4, 6, no, 12.
2, 4, 6, 8, 10.
No, 10.
2, 4, 6, yeah, 8, 10, correct.
Yeah.
Yep. So as long as the rails are annotated AB, AB, you'll have no problem with this scenario. Because rail A will always be to rail A and rail B will always be to rail B. Okay?
So if you don't want to use a toggle switch to move your turnout, then it would be done. You would just manually just throw it right here, right? Is
That's
that
correct.
Okay.
Yep. However, you get back to the fact that you're relying on the conduction of the throw points here to meet the stock rail to make your electrical connection through. Okay?
Or an electrical frog. So since I'm not running that wire out of here, these were dead. So I had to connect this one to this one, and I had to connect this one, I had to connect this one to this one.
That's correct.
And this one to this one.
Right.
Once I did that, I had kind of,
You had connectivity. Yeah.
So Mike, what would be your preference, or what maybe fail safe on when you put a turnout in? Would it be better just to put wire?
It depends on the size of the layout, really. I mean, if you're doing just a small layout, I don't have any problem with rail joiners, doing the conductivity.
Okay.
When do you use isolators?
Use isolators when you want to isolate a track for power situations such as a siding. You bring a train into a siding, you want to shut off that track. So you would put isolated joiners, and those are the plastic joiners, into your turnout, somewhere in the turnout on that siding, and that would be powered independently so that you can turn that on or turn that off. Okay?
I guess the way you would do that is, once you have the insulated and you have the siding, When you run those feeders, you just put a switch on the feeder.
That's exactly correct.
Okay.
And that's it, yeah. That's it. So then, and that's the purpose of those rail joints, just isolation. So it's not part of the electrical path of the entire layout.
And that way you can have stuff back there without
Yeah.
engines running all the time.
That's exactly right. And you can do that,
Oh, yeah, keep
you can
saying.
do that on a single, you can do that on a single rail or do both rails.
Right.
Either one. So if you're doing common rail, where one rail is hot all the time, and then you're switching on and off the second rail, okay, then you would just need a single rail joiner in that rail to isolate that particular track. Okay? Okay. So what I wanted to do is just give you an overview of the tools. Like I said, these are okay, but you need a file. These are better, you still need a file. Okay?
If you wanted to throw these, if you wanted to use these as to do an automatic throw, how do you go about doing that, or can you?
Automatic in what sense, Mark?
Well, wait, if you push the button, it does it automatically.
Oh, okay. In a remote, yeah. Okay, so that's two totally different circuits. You have one circuit that is just switched power for the coil in the remote. Okay, when you press the button, that'll activate the coil.
These are not remote right now.
They are,
Manual.
well, this one is electric. This one was electric. I'm certain that, you know, if you powered this up, what you would do is you would put on, this is a three-wire terminal. So the common bus would go to the center, and then your switched lead would go to either inner or outer on this, and that will give you the polarity throw, either out or in on your coil. Okay? You have to be careful when you're doing that, though. You don't want maintained connection to the coil. You just want momentary. So you want to always use a push button to operate your throws. And the reason for that is if you use a constant power, the coil is going to burn right out on you. Okay? Normally, when I was doing DC block control and DC, regular DC, I had built capacitive discharge units that would power all of my turnouts on there, because when I was throwing turnouts, I was throwing out 4, 5, 6 turnouts at a time. And so a capacitor would charge up, you'd hit the button, boom, it would discharge a high voltage to that and just shock them and throw them solidly and then disappeared. So if you do that, you know, you can run these at their 12-volt devices. You can run these at 36, 48, 56 volts, not a problem, as long as it's momentary spike. So push button will give you what you want to do.
So is that different than a toggle?
Toggle switch gives you a selection of whether you want turnout, out, or through. The toggle gives you direction.
Okay.
You don't want the toggle to actually power. You want the toggle to give you selection, and then you want the push button to give you the power.
Gotcha.
What about the Atlas sliders for the switches?
Well, the Atlas sliders actually have a break point in them so that when you slide them, they're actually momentary contacts. Okay? So they've already built that in for you. So you can actually throw those, leave those in position, because what the contact does is the contact closes and then opens, but the actuator stays in a position to give you an indication of whether your turnout is thrown or through. Okay? So, all right, anything else? You guys okay with this?
Tortoise, right?
I'm sorry?
Tortoise does the same thing, right, as far as the tortoise? The tortoise does the same thing, right?
Nope, tortoise is a mechanical throw.
Okay.
Tortoise is a motorized device that links to your turnouts through means of a spring pin. Okay, and all the tortoise does is the tortoise moves out or in, so it gives you linear motion when you turn the tortoise on. There's a little motor in there. And what that does is that moves a trip pin to either this way or this way. And that's connected from the underside to your throw bars on the rail, and that will move your turnout in or out. Okay? Now, you go back to that, what I said before about selectivity, you have a selector switch that gives you direction control on your tortoise. So it either tells the tortoise you want to go out or you want to come in, okay? The difference with a tortoise is that they are designed so that you can maintain power on them all the time. That's the difference. So those you can do with a toggle switch, okay?
So how would you connect it to these turnouts? You just-
Tortoise would be mounted up underneath,
Okay.
and then a pin would come up and you go through a hole in the throw bar, and these do not have holes in the throw bar, but you'd have to drill a hole in the throw bar,
Okay.
okay? And so now that,
This is a throw bar here, right?
yeah, you can do it from here. Yeah, the picos actually are done from the center, okay? But yeah, on these, I didn't even notice that there. So yes, what you would do is you can hook up that pin coming up right to the throw bar. And as the pin moves in or out, it will move the
The switch in.
switch in or out, okay?
They're not instantaneous.
No, they're slow. They're designed to be slow, okay? But like I said, the tortoise, you can use just the selector switch and power through the selector switch, okay? Because the tortoise motors are designed to be stall motors, which means that they can maintain power on all the time without burning them out, okay? So you throw the switch out and tortoise will move to an out position. Flip the switch, it'll move it to the in position, and you can leave the power on all the time. That's not a problem, okay? But with these Atlas controllers or these small coils, whether they're Picos or they're Atlas, with these small coils in here, you cannot maintain power all the time on them. So that has to be momentary.
When you already have the track laid, and you want to upgrade your system to a tortoise, I guess my question is, how are you going to drill that hole up through there?
Very
or down
carefully.
through there?
Very carefully. I've made a template out of a piece of Lexan, okay, that gives me the drill mounting holes for the tortoise, and it gives me the position for the hole for the throw bar actuator, and I can do that from underneath the layout. Okay, very difficult to do it through the top of the layout. Okay, but if you do that with a drill bit that has a stop function on it, like a piece of tubing or something on it to limit how far you go, you only need to get up through the plywood on that. And once you locate yourself underneath, the template will tell you where to go. Okay? On these are relatively easy. I would take a template, lay it on there, drill my holes right now before I set the turnout in place. But on existing, as you asked, a little more difficult, because if you come up in the wrong place, you're going to hook a rail with a drill, you're going to hook a tie bar, you're going to do all kinds of stuff that you don't want to do. You're going to create more work for yourself. All right? So don't be afraid to cut the rails. It's not a big deal. Okay? Measure twice, cut once, and cut clean. Don't say I cut it six times and it's still too short. You know, it's all right.
Well, Mike, thank you for giving us this demonstration. We do appreciate that.
For more information about the Apple Valley Model Railroad Club, visit their website at avmrc.com.